Hey chemistry crew, Mr. Color here. Today I'm going to go over pages 30 and 31 in your gases packet, which is a review of everything we've done with gases, and a lot of it's kind of all mixed together. This mixed practice really shows what you know and what you remember about gases. So, question number 1 here asks if the volume of a gas is 19.4 liters at 4.99 atmospheres, what is its volume at 1580 millimeters of mercury? So this is relating a before and after of pressure and volume. So I need to pick the equation that has pressure and volume, and that's P1V1 equals P2V2. Also, since my units for pressure are different, I have atmospheres and millimeters of mercury, I need to convert one of them. It actually doesn't matter which. Here I converted millimeters of mercury into atmospheres and then plugged that value into the equation. You would get the exact same value though had you converted atmospheres into millimeters of mercury. Then you've got P1V1 equals P2V2, and I'm solving for V2, and I get my answer. Question 2 here deals with partial pressures. We have nitrogen with a partial pressure of 1.22 and carbon monoxide with a partial pressure of 87.4 kilopascals. What's the total pressure in atmospheres? So I need to convert the kilopascals from the carbon monoxide into atmospheres. So here's me doing that conversion. Once I have the partial pressure of each in the correct units, I simply need to add them together. There's my partial pressure in atmosphere, my partial pressure in atmospheres, giving me my total pressure. Number 3, a student drops zinc into a beaker of hydrochloric acid and collects the hydrogen gas being produced. That's a single displacement reaction. The volume of the balloon is 812 milliliters. The temperature of the room is 21 Celsius. What volume would this balloon occupy at standard temperature? So here we have temperatures and volumes before and after, right? So we're going to use the equation V1T2 equals V2T1, or this is could also be written as V1 over T1 equals V2 over T2. I just rearranged it. So we're looking at temperatures and volumes. So I'm going to take my initial volume, multiply it by my new temperature, and divide it by my original temperature to get the different volume that it would occupy. Next up, number 4, we've got volume, temperature, and pressure in an initial scenario, and then asking for a new volume with a new temperature and a new pressure. So this is one where we're going to use the combined gas laws, P1V1 over T1 equals P2V2 over T2. So I'm going to plug in those initial values. The only thing I need to convert is temperatures need to be in Kelvin. However, the pressures I do not have to convert for the combined gas law. As long as they're the same pressures on both sides, that's fine. There's no constant value, so there's no required units for that. However, we do have to use Kelvin. Plug them in, solve for your unknown, get your final value. Number 5 here, what is the pressure of 2.94 grams of C2H8 if it has a volume of 83.2 mil at negative 24 Celsius? So this is not a before and after. This is just a what is the pressure if these are the circumstances. The fact that we've got grams tells me that we're dealing with moles in here as well, and that's a telltale sign that we're going to use the ideal gas law equation. So since it's asking for pressure, I took the ideal gas law equation, PV equals nRT, and I've rearranged it to solve for pressure. Now, 2.94 grams, that is not a number of moles, which I will need N. I will need number of moles here. So I'm going to convert that to moles by dividing by the molar mass of C2H8, which happens to be 32. That gives me the number of moles. Now I can plug my values in. I've got moles. R is that gas constant. That is a number you don't need to memorize. It's on your reference packet. I take my temperature, I convert it to Kelvin, and I take my volume and I convert it to liters. So this one had a little bit of everything. We had to convert from grams to moles, from Celsius to Kelvin, and from milliliters to liters. And then we also had to rearrange the equation for pressure. So a lot going on for that one. So number 5 is a very good check for whether you understood the ideal gas law. Number 6, we've got a volume and a pressure And then we are asked what the new pressure would be with a new volume. So this is your P1V1 equals P2V2, right? We're going to plug in our numbers, solve for the unknown. I did do a one conversion, which is this first value was mils, but this second value was liters. So I just converted them both to mils. You'd get the same answer if you converted them both to liters. Answers are at the bottom of the page as well. Page 31 is next. We're in the home stretch showing everything we know about gases. Here we've got a volume and a temperature, and we're asked for what new temperature we would have at a new volume. So we've only got temperatures and volumes. So I'm going to use V1 over T1 equals V2 over T2. My initial volume, my initial temperature, that's this 19 Celsius, but converted to Kelvin. My new volume, I converted to mils so that they were both in mils. And then my new temperature here, and there it is. It did not ask me to convert it to Celsius, so I didn't. How many grams? Anytime you see grams, you're triggering that we're looking for moles. And since we're looking for moles, really the only thing we did in this chapter with that was the ideal gas law. So I've rearranged the ideal gas law equation to solve for moles. We are dealing with a volume of 36.9 mils, so I'm going to convert that to liters. We're dealing with a pressure of 158 kilopascals, so I'm going to convert that to atmospheres. Remember, anytime you're dealing with the ideal gas law, each value has to be in a certain unit. Pressure in atmospheres, volume in liters, and temperature in Kelvin. And finally, there's my 72C, which I converted to Kelvin. I solve for all of this, and I'm going to get a number of moles. Now, I'm still not done yet. It wants me to convert to grams. So now I'm simply going to take the moles and multiply it by the molar mass of the gas in question, which is carbon dioxide. That gives me my final value. Number 9, what is the pressure? Okay, so could be a couple of different equations of this volume at this temperature, okay, if it occupies a volume of 82.1 at this temperature and this pressure. Oh, okay, so this is a combined gas law problem because we're dealing with temperatures, pressures, and volumes, and we're dealing with before and after. So there's your P1V1 over T1 equals P2V2 over T2. I don't know the pressure of this 37.9 mils, so that's where I keep my P1, my unknown here. I do know its temperature, 39. I add 273. That's where this 312 came from. Then we're going to have our new pressure, 2.33 atmospheres, our new volume, 82.1 mils, and our new temperature, 15 Celsius converted to Kelvin. Cross multiply, solve for P1, and you'll get your answer. What is the total pressure if 60% of the mixture, which is oxygen, is 800 mils? So if 60% of the total equals 800, then the total can be solved for by dividing 800 by 60% or 0.6, and you'll get 1330 is the total. These percent ones are pretty easy to mess up, so just check that work and make sure that's how you approached it. Couple conversions, threw these on at the end just to make sure you're remembering how to do these. So here's kilopascals to millimeters of mercury. So we need to find the relationship between millimeters and kilopascals. So there's 760 millimeters per 101.325 kilopascals. Both of those I got from the reference packet. Those aren't numbers you have to memorize. There's your final answer. And millimeters to atmospheres, well, atmospheres, that's nice. That's the one that has the number 1 with it. So we're just going to do 758 divided by 760 and get the same number of sig digs we started with. And that's what we do when we do these conversions. So in this first one, number 11, we had 4 sig digs, so I gave you 4. In this one, we started with 3, so I gave you 3. That should be everything you need. And hopefully this gas stuff is making sense and you're feeling good about it. Let me know if you have any questions.